Since you're complaining so much about the network. Mm, okay. So this is, so whatever we're doing here, from here going down, is just solving the quadratic equation, which I know you guys can do that, is it? So there are only two steps here. The first step is to let the 2 to the power x be equal to y. After you substitute wherever there is 2 to the power x, you put y. Then you cross multiply and have a quadratic. Then solve the quadratic. After you solve the quadratic, then now we are here. We want to find the values of x. Now, 2 to the power x is equal to -3. This one is not possible. So here, not possible. But the other one, 2 to the power x is equal to 5. We can apply ln here and apply ln there. Ln there. So we can apply ln there, so that when we apply ln, we can drop, using that property of dropping, we can drop the x from being the power to being the coefficient, and then we'll have ln 5. So if we can divide by ln 2 and divide by ln 2, then we'll get x to be ln 5 over 2. Ln 5 over ln 2. Ln 5 over ln 2. So the reason why this is not possible is because if we were to apply ln on 2x and also ln on -3, it means that this guy is not defined. Remember, I said the domain for all logs must be x bigger than 0. So that's what
Sir,
I mentioned. Yes.
sir, I have a question.
Okay.
So it's not okay if you use log, like log of two to the power x is equals to log 5.
It's okay.
All
So
right, thanks.
where ln is used, even log can be used. Okay, so whenever you meet such type of questions, the idea is you want to solve for x. So to avoid getting confused, in the first place, you let that your x, that your 2 to the power x be just some letter like y. As you can see, it becomes so easy to solve the quadratic that are such kind. Later on, when I found the values of y, I replace there. If there's anyone, if there's n that is negative, I drop it off and pick the ones that are positive and then move on. Okay? Okay? So if there are no questions, we can move to the next one. And the next question is B differentiate from first principle. So we use first principle. Part one, the function of f of x is equal to the root of 2x plus 1. Okay, so to differentiate from first principle, you say f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x, then you divide by h. So that will be lim as h goes to 0. So what is f x plus h? This means in your original function, where there is x, substitute x plus h. If you expand this, it will be 2x plus 2h plus 1. Like that. So you go back to the lim and substitute. Here we put 2x plus 2h plus 1. And then minus, you bring back the original function. And then the h down. Okay. Now the idea is we cannot put 0 where there is h, because the denominator then will make everything here undefined. So what do? We rationalize the numerator. So we multiply like that. So this will be 2x plus 2h plus 1 plus 2x plus 1. And also down, we multiply by the same. Okay. So we'll get the lim as h goes to 0. So by this time, we already know the results of rationalization. So when you multiply the first by the first other side, we remain with 2x plus 2h plus 1. And then the middle parts, when you multiply the first by the last and the second by the first, we know that those will cancel each other. So if they cancel each other, then we can subtract minus. So you know, again, when you multiply, we are going to have minus 2x plus 1. So we can expand it, so it can give us minus 2x minus 1. Like that. Okay, and then the denominator remains the way it is. H, the root of 2x plus 2h plus 1 plus the root of 2x plus 1. So these would subtract. Okay, so now we have lim as h goes to 0 of 2h over h, and then the root of 2x plus 2h plus 1 plus 2x plus 1. Okay. Then we divide this h by that h. After you divide like that, the h, which was a problem, has now gone. So now we can find the lim. So where there is h, we can subtract, you can substitute as 0. Wherever there is h now. So we'll have the root of 2x plus 2. There is h there, we put a 0. like that. So the idea is we've now canceled out the what? The h, and substitute wherever there's h, we've put a 0. So we have now found the limit. We're just simplifying here. So we have 2 over, if we add this plus this, since they are equal, let me show you that they're the same. So now we have 2x plus 1 plus 2x plus 1, since the other middle part is 0. So now we have these 2 and then this. So we can cancel again, 2 here, 1, 2 there, 1. So that we get 1 over the root of 2x plus 1. So we don't need to get puzzled there as in what's happening. Hello.
I wanted to ask, when you're dealing with the first principle, the idea is that the numerator is always supposed to have the type of h.
When
you're dealing with the first principle, the idea is that the numerator is always supposed to have the type of h.
The numerator should always produce the h. Whatever remains in the numerator must have h. So we can factor out that h to cancel the one from the denominator. Even if it has more h, like h power 3, h power 2, for as long as each part has h that you can factor out and cancel the one that is down, that is always our mission. Okay. Do we have any other questions there?
No, sir.
Yes. Yes. Okay. The next one, still on first principle. That was 2. F of x is equal to 1 over x minus 1. So before we bring the formula, we know that we will need f of x plus h. So let's find it. So it will be x plus h minus 1, like that. So we can go to the derivative, which is lim again, as h goes to 0, of f of x plus h minus f of x over h. That is lim as h goes to 0, 1 over x plus h minus 1 minus 1 over x minus 1, and then we divide by h. So that the lim as h goes to 0. So as you can see, the numerator there, those are 2 fractions. So we get the common denominator, x plus h minus 1 multiplied by x minus 1. And then when you divide, okay, so when you divide the x plus h minus 1 into this one and then multiply by 1, we'll get x minus 1 minus x plus h minus 1. And then, of course, there is over h down. Okay. So we have lim as h goes to 0. We expand again, x minus 1 minus x plus, sorry. Since we're expanding, so this will be minus h and then plus 1 over x plus h minus 1, x minus 1. And then we divide by h. Okay. So what do we notice here? We see that in the numerator, this x minus that x, that's 0, minus 1 plus 1, we go, and then we remain with minus h over x plus h minus 1 multiplied by x minus 1, everything over h. So that h and this h cancels. So now we remain with minus 1 over whatever there is h, we can take 0 once we cancel that h that is down there. So now we have x minus 1 times x minus 1, which you can leave like that or write it as minus 1 over x minus 1 squared. So that's almost the same principle there. Okay. So you always do that. What has happened for you not to see the screen? So the questions on first principle, I don't expect you guys to struggle there. So they're expecting either the root in the numerator or the root in the denominator. Either ways, you rationalize to get rid of the root. Until that h that you put down there in the formula is cancelled. Just after managing to cancel that h, then you can substitute now to the h remaining, you place 0 wherever it will be. So we still have a lot of questions to do. So the next one was C. Matrices we haven't done. They're not in the coverage. Vectors we haven't done. So we're coming straight to 2B where there are identities for trig. Partial fractions are not in the coverage. I don't know if I'm right. I think I am. Then we'll go to 3 where there are graphs. Cramer's rule is not there. So go to binomial, continuity. Yeah, so when you join, we'll finish it. So it will be logged out. We are doing the paper for last year. Last year, test 2B. Remember last year they had A and B. Now we're doing last year's test 2B. But that's not a big deal. So this is just guiding us. Say, oh, should they talk about first principle? This is how we go about it. Should they ask us to solve logs? This is how they go about it. Should they ask us to solve exponential? This is how we go about it. Should they ask us to do identity? This is how we go about, that's what we are doing today. Just trying to refresh on every part. Oh, I'll send some listeners. All right, so wait for 10 minutes and then we join. We are joining at the 18 hours. So no one will remind you, just join and start then. Let's take a enjoy a break.